Okay, let's consider this type of related rates problem. There is, say, a common reference point O between two ships, and they're both moving away from this reference point, and they're doing it in such a way that the angle between their lines of travel is 120 degrees. And one of the ships, say ship A, is moving at a speed of 20 miles per hour. That's ship A. And ship B is moving away at a speed of 30 miles per hour. And that's for ship B. Now, we're asked this problem when ship A is 8 miles away from the reference point and ship B is 6 miles away from the reference point. How fast is the distance between the two ships changing? So, here's the distance of ship A from the reference point. That's 8 miles. Here's the distance of ship B from the reference point. That's 6 miles. And now this line segment here, which we'll call H, that's the distance between the two ships. And we want to know how fast is this distance changing at the moment when ship A is 8 miles from the reference point and ship B is 6 miles away from the reference point. So let's see, what information are we given? We know what, let's call this segment here, we'll call OA. We know that d of OA dt, that equals 20. And we know that d of OB dt, that equals 30. And we want to find the h dt when A, or OA, that's the distance of the ship from the reference point, equals 8 miles, and OB equals 6 miles. So, to do that, we know what this rate of change is. We know what this rate of change is. We want to know what is this rate of change, essentially. So we need to find an equation then that relates these distant variables here. We have 3 of them. The distance of the ship A, the distance of the ship B, and the distance between them. And here's where we use the cosine law. H squared equals OA squared, that's this distance, plus OB squared, that's this distance, minus 2 times OA times OB times the cosine of the angle between them. And the angle between them is 120 degrees. Remember now, the cosine of that is over here, so it's negative. The cosine of 60 degrees is plus 1/2, so the cosine of 120 degrees, that's minus 1/2. So this, for 120, that is minus 1/2, which makes this a plus and takes the 2 away. So we can rewrite this, take out the 2, and a minus becomes a plus. So h squared is equal to OA squared plus OB squared plus OA times OB. And we know what the derivative of this is, and the derivative of this. Now we want to find what is the derivative of this, what's an expression for it, and what is its value going to be when OA has this value and OB has this value. So here we take the derivative of both sides of the equation, and we have 2h dh dt equals 2 times OA times dOA dt. Just took the derivative of this and the derivative of this, plus 2 times OB times the derivative of OB with respect to t. And now here we have a product. So it's going to be plus OA times the derivative of this one, OB dt, plus this OB times the derivative of OA. So those are the derivatives with respect to t, and we know what this is. We know what this is here and here. And we're also given what OA and OB is. We still don't know what h is when OA equals 8 and OB equals 6, but we can find out. So let's do that right now. H squared will equal OA squared, that's 8, squared is 64, plus OB squared, that's 6 squared, so that's 36, plus OA times OB, 8 times 6. So h squared, 100 plus 48, h squared equals 148, h equals square root of 148. So it looks like we have everything filled in on this rather long equation except for this. And that's what we wanted to solve for. So we have 2 times this 2 times h, which is this, square root of 148 times dh dt, that's our one unknown that's left here, and that will be equal to 2 times OA, that's 8. 2 times 8 is 16, times 20, plus 2 times OB, that's 6, that's 12, times DOB dt, that's 30. So this is times 30. Plus OA, that's 8, times DOB dt, that's 30. Plus OB, that's 6, times DOA dt, that's 20. Okay, and it looks like we've got a Q on this side. So here, take that out. That can be 8 times 20, 6 times 30, 4 times 30, and 3 times 20. So let's see, this will equal, this is 160 plus 180 plus 120 plus 60, and that's dH dt times this, so dH dt will equal this sum here, 160 plus 180 plus 120 plus 60. Now divide both sides of the equation by the square root of 148, and that is what dH dt will be equal to. And let's see, we have here 300 plus 220, looks like that's 520. And this is 37 times 4, so that would be 2 times the square root of 37, and this would be 260, so 260 divided by the square root of 37. That in miles per hour then is dH dt. So 260 divided by whatever the square root of 37 is, it's a little bit more than 6 obviously. That is what dH dt will be. And that will be in terms of miles per hour. So that right there then is how fast the distance between those two ships are changing when one ship is 8 miles from the reference point and the other ship is 6 miles from the reference point. This is moving away at 20 miles an hour, this is moving away at 30 miles an hour, and they maintain this angle between them of 120 degrees. So that's it. Hope that was helpful. Come back for some more videos, and we'll try and slug our way through some more problems.